2016 marked the end of one of the strongest El Niño events ever recorded. It triggered unprecedented floods in South America. Northern Europe witnessed heavy flooding too. But all that was to change several months later as the planet experienced the hottest August on record. Extreme droughts in several regions sparked massive wildfires. The high surface temperature of the oceans fueled severe storms in the Atlantic and the Pacific.
We had, for the first time in the Atlantic, 2 intense hurricanes at the same time that had not been seen before.
We can predict those storms, but we still can't foresee one of the planet's most lethal natural disasters: earthquakes.
We've seen a number of medium-sized disasters which may cost billions to tens of billions of dollars.
Using only professionally shot footage capturing the heart of the action, this film presents the major natural disasters of 2016, from the least deadly to the most dramatic. In the southern hemisphere, the climate provoked a catastrophe of unusual proportions in the capital city of Paraguay, Asunción, which lies on the banks of the Paraguay River. At the beginning of the year, torrential rainfall affected the river's catchment area in Paraguay and the surrounding countries. From late December, heavy rains, driven by a strong El Niño, increased river levels in Paraguay, Argentina, Uruguay, and Brazil. But what exactly is El Niño?
The El Niño phenomenon, which owes its name to the period it normally arrives at, right around Christmas time, comes from the nickname of Jesus Christ in Spanish, El Niño.
This recurring phenomenon begins when warm water in the western tropical Pacific Ocean shifts eastward along the equator towards the coast of South America. During an El Niño, the Pacific's warmest surface waters sit offshore of northwestern South America.
The rising temperatures in the East Pacific move the rain from the east of the basin, so it creates rain anomalies and very rainy phenomena, with flooding on the east coast of South America.
In Asunción at the beginning of January, flooding forced over 150,000 people from their homes. Parts of Asunción had already been experiencing flooding since November. By mid-December, the levels of the Paraguay River had reached over 20 feet, the highest of the year at that time, and well above the 18 feet considered to be the critical stage. Many feared the worst. Thousands were evacuated from neighborhoods along the river as levels of the Paraguay rose to 26 feet on January 7th.
Every year, the flooding gets worse. It's a place where the river keeps getting bigger and higher, and recently it's been out of control. In December, I couldn't get here. Today, I made the effort to come for my father. You see, it's not easy to get to. It's an area that's very prone to flooding. And it gets worse and worse with the rain coming from Brazil and Argentina. It's hard because we have to make a lot of sacrifices. People always think that this time will be the last time, but it keeps on happening. History repeats itself. People start rebuilding, and almost before they've finished, it starts again, and everything is washed away. My father has his whole life here, his animals, his family. He doesn't want to leave.
Around 6,000 families were affected in the first weeks of December. But when river levels jumped to over 23 feet, these numbers doubled. 13,000 families were hit by flooding, most of them from the poor Los Bañados area of the city, located close to the river. The government of Paraguay declared a state of emergency in Asunción and 7 other regions of the country similarly affected. El Niño events occur irregularly, roughly every 2 to 7 years, and last from 12 to 18 months, bringing with them risks of repeated flooding in vulnerable areas and the danger of outbreaks of cholera and malaria. At least 200 pylons were damaged in the rains, leaving thousands without electricity. And 4 people were killed by falling trees in what has been called the worst flooding in 50 years. The government immediately made $3.5 million available to help those who had been affected. As the climate changes and gets warmer, ocean temperatures also increase. And warm oceans fuel hurricanes and typhoons. In 2016, Taiwan was particularly badly hit by typhoons, just as new research pointed to the fact that the power of these destructive storms has increased by 50% over the past 40 years. The Pacific typhoon season started late in 2016, with the first named tropical storm, Nepartak, only developing on July 3rd. The storm began its life as an area of low pressure over the eastern Caroline Islands on June 30th. On July 5th, it was upgraded to typhoon status. By the end of the day, with sea temperatures over 30 degrees Celsius in the Philippine Sea, Nepartak was declared a super typhoon. It reached peak intensity near Taitung on the southeast coast of Taiwan, with wind pressure at 900 millibars and maximum sustained winds of 125 miles per hour. Nepartak crossed over Taiwan on July 7th.
Eastern side, it has big mountains, and not very many people live on the east. Almost all the activity, the economic activity, the big cities, almost all the people and the buildings are concentrated on the western side of the island, the lowland side of the island. And most typhoons, they come from the direction of the southeast, and so they tend to hit the mountains first.
Nepartak caused 3 deaths in Taiwan, but went on to cause 83 deaths in China, and a total of $1.5 billion worth of damage. 3 months later, a second typhoon hit Taiwan. Named Meranti, it was the strongest tropical cyclone worldwide in 2016 and one of the most intense tropical cyclones on record. The storm formed west of Guam in the western Pacific Ocean. On September 11th, it was upgraded to typhoon status, rapidly intensifying on September 12th and becoming a Category 5 super typhoon with maximum sustained wind speeds recorded at 150 miles per hour and a minimum barometric pressure of 890 millibars. Meranti clipped the southern end of Taiwan. Two people were killed and over 700,000 homes lost water and electricity. The storm went on to destroy nearly 300 houses in the Philippines and kill some 30 people in flood-related events in China. On September 21st, again near Guam, a tropical depression formed, becoming Typhoon Meggy on September 23rd. The typhoon reached peak intensity as a Category 3 typhoon, this time over the island itself, making landfall at Hualien City on the Pacific east coast of Taiwan, with maximum sustained winds of 100 miles per hour and a barometric pressure of 940 millibars. Giant waves battered the coast as Meggy landed, leaving over 3 million households without power in the second worst blackout in the country's history. However, given the size of the waves, the damage was not nearly as bad as it could have been.
The last of these typhoons brought quite high wind speeds, so wind speeds that in most countries would have been quite damaging to Taiwan, in particular to the main port at Kaohsiung in Taiwan. It brought very high winds, but it didn't do a very large amount of damage because the buildings in Taiwan are quite well built.
As the storm's eye passed over the island, the winds changed direction. Meggy forced more than 14,000 people to evacuate to government shelters from mountainous areas near the coast. Even though Taiwan and southern China are well prepared for such events, 91 people died, and the total cost of these extremely destructive typhoons has been estimated at $1.25 billion. Researchers are warning that these giant storms will become even stronger in the future, threatening the large and growing coastal populations of Pacific nations. Other events are likely to become more devastating as a direct consequence of human population growth. 2016 illustrates the challenge of living on a tectonically active planet. The Pacific Ocean is circled by a network of tectonic fault lines and volcanoes known as the Ring of Fire. To the northwest of this ring are Honshu and Kyushu, Japan's most populated islands, which lie at the junction of several plates. The Philippine Plate collides with several Eurasian plates, creating a fault line that loops under the islands from southwest to east. At the extreme south of this zone, the Kumamoto district is built on layers of rock. Every year, dozens of tremors are felt in this area. In April 2016, a series of earthquakes hit the Kumamoto area, including a magnitude 7 main shock on April 16th. It was centered around 60 miles southeast of Sendai, close to the site of the devastating quake and tsunami that struck in March 2011.
These earthquakes in Kyushu, they weren't located on the subduction zone plate boundary. They were located on a zone where there's a lot of active faulting running down the middle of Kyushu.
Roads were damaged and thousands of homes were destroyed in the earthquake, Between the 14th and the 20th of April, the area experienced more than 600 aftershocks, including 2 very strong ones. 15,000 soldiers from the Japan Self-Defense Forces joined relief efforts.
The main priority we have at the moment is looking for people and saving them. And to be honest, it's been very frustrating, because we can't do anything at all for the moment. The aftershocks keep continuing. We need to be very careful because nature isn't making us feel very optimistic.
As well as destroying houses and buildings, the earthquakes triggered landslides across the Kyushu mountain range, leaving scars on the hillsides and forcing the collapse of the Great Aso Bridge into the Kurakawa River. This was an unprecedented event in the area's living memory.
We already had several large landslides 5 years ago. They were declared national disasters and they caused a lot of damage. I'm not sure if these ones are bigger compared to the ones we had previously, but they are ongoing. And huge rocks that had never moved before have fallen this time. You can see on the mountain areas that the soil is red as a result of landslides.
On April 17th, Japan's Prime Minister Shinzo Abe mobilized 3,000 personnel from the Air Force to help local authorities reach impacted areas.
I am part of one of the search and rescue teams. At the moment, we are looking for people who have disappeared. It is the first time that we have seen an earthquake and a landslide of this size. Since I arrived here, we have found 4 people. 1 person is still missing, so we are going to search all night. It is a natural occurrence, and nobody could see it coming. We have no warning. We don't know where the houses have been carried off. We are doing research based on assumptions.
Time is running out to find survivors. The team prepares for a sleepless night.
Three people in Yamaguchi. They haven't arrived yet?
They've already gone down there.
They've already gone down. And the last one? Our one? Okay, that's all. Now we'll go down. I'll lead the way.
Are we on the list?
2 people? Yes. You can come with us.
Dozens of people were pulled from the rubble in a desperate effort to find survivors before the forecast rains began. On April 18th, 24 people were found dead. 11 were still missing, and more than 91,000 had been evacuated. The number of people seeking shelter had risen to 180,000. As a result of the tremors, the entire city of Kumamoto was left without water. By April 19th, the continuing aftershocks drove even more local inhabitants to sleep in their cars, stadiums, and open spaces. Government officials estimate that more than 1,000 buildings have been seriously damaged, with 90 completely destroyed.
The epicenter of the first one was at Mashikimachi, and then the second earthquake was in the Aso region. When the second earthquake hit, the house collapsed. It happened at roughly 1:25 in the morning. It felt like my body was being thrown from one place to another over several feet. I was just there, where the table in the living room is, under the clock. I was sleeping under the table because I thought it would be safer and that it would protect me if something fell on top of me. That part was 2 stories high, and underneath there was the garage and my bedroom. It's terrifying to think what might have happened to me if I'd been in my bedroom at the bottom. The car was squashed like a pancake. For the last 5 years, once a year we have an earthquake of about 3 or 4 magnitude. I think it was a sign, a warning sign.
Although the focus of the earthquake was underneath Mount Kimpu, to the northwest of Kumamoto city center, the worst-hit areas were Mashiki and Mikubo in the eastern suburbs. On the 21st of April, as feared, bad weather arrived, adding to the rescue team's difficulties. Rainwater runs into cracks, bringing with it the risk of provoking landslides on the unstable ground.
The cliff is slowly collapsing because of the rain. The inhabitants of the houses living below the cliff have all been ordered to evacuate the area. We are actually in the process of checking if everything has been taken care of.
Among the most exposed were the houses around Aso, where the active fault moved the ground 6 feet sideways on April 17th. The building's foundations are now anchored into land that the earthquake has turned to soup.
There's nothing we can do, faced with the power of nature.
I comfort myself with the thought that there was nothing I could have done about it. There are only 2 of us in the house. We're thinking about living with other people now, even in temporary housing for a short period. All the houses here were destroyed the second day. The first day, the road started to worsen. 3 pine trees and an electrical pylon fell on my house. My legs tremble with fear.
Around Aso, solid earth turned liquid, swallowing cars and roads, and even toppling buildings that had been resting on the weakened soil. This liquefaction has been the most destructive part of the disaster. Scientists have long tried to study the phenomenon, but now researchers say that many of their models are flawed and fail to accurately represent real-world conditions.
Liquefaction usually takes place in sandy soils. When the sand is mixed up during the tremor, the pressure means that the ground turns to liquid. That causes weaknesses in the ground, and the houses lean over, like that one behind us, because the ground can no longer support it. The ground here also has a particular geological feature, which is that it's covered with volcanic ash, which has built up on the sides of the mountain.
Amidst the turmoil and confusion, a team of Japanese seismologists is taking measures in an effort to establish a 3D model of the area affected. They are trying to understand the region's tectonics and the forces in motion.
If you look at this area over here, you can see that it has turned into a sort of staircase. The ground is very soft. I think that when large parts of the ground slipped, the surface kept on slipping, and it's not often you see a mountain collapse like that.
Japan is constantly under threat from new quakes and volcanic eruptions. The whole country is under the continual scrutiny of seismologists and volcanologists. 20% of the world's earthquakes hit Japan each year, around 600 per year. In 2016, another violent quake measuring 7.1 magnitude was felt on November 22nd in northern Japan, near Fukushima, causing more fear than harm. Altogether, the Kumamoto and other Japanese earthquakes of 2016 killed 49 people and caused an estimated $7.5 billion of damage. A few months after the Philippine tectonic plate made headlines in Japan, another tectonic plate caused havoc in Italy. The Mediterranean basin is crushed by the African continent, moving under the Eurasian plate, which generates complex subduction faults. Trapped in the middle, the Adriatic plate rotates in an anti-clockwise direction at a rate of 1/10 of an inch per year around the city of Amatrice and the neighboring villages of the Apennine mountain range in central Italy. The isolated mountain villages are known for their olive oil, black truffles, and vineyards. At 3:30 a.m. on August 24th, a shallow but strong earthquake measuring 6.2 magnitude took the villages by surprise. The towns of Arquata, Pretare, and Pescara del Tronto, among others in the region, were badly damaged. Local priest Francesco Armandi is the living memory of these villages.
On the night of the 24th of August, at 3:36 to be precise, we heard a loud crash and the ground shook violently. I was in bed, but I was awake, and we had the impression that nature was trying to make my bed hit the ceiling. I waited until the end of the quake, and I got dressed quickly and went out. The streets were full of rubble, stones, and big rocks. The whole population was in the street.
I got up, I put my slippers on and got my son, and even before the first quake was over, we were already on the staircase. At the bottom, we realized that we were in our pajamas at 3 o'clock in the morning. When the second tremor hit, we heard the Mount Vittori. It made a terrible noise. At that moment, everything crumbled. I said to myself, Mamma mia.
Not only that, we were just in the car park next door. when we heard a noise of stones from the summit of Vettor that were rolling down with the tremor from the earthquake.
In 10 minutes, you look around you and you see the disaster. My house is still standing, but you can't live in it. It's as though everything has come to an end. And looking at your village that no longer exists is even harder. The school bus arrives here. I've picked my son up here lots of times. I would give him his snack. We'd go to the bakery. That was our life. Simple, basic, but it was our life. It's gone now. I'm sorry.
In addition to the loss of human life, some of Italy's important cultural heritage was also destroyed.
A church collapsed at Pescarabi. It must have been 1,000 years old, and it's never collapsed before, even though there have been other earthquakes, which must mean that this one was much stronger.
These are not the colossal tremors we see at tectonic plate boundaries, where events occur measuring 8 or 9 magnitude. The effects in this region are devastating. Because the quakes take place near the surface of the crust, these small faults are shallow, causing dramatic shaking above the site of the quake.
The truth is, we're just one little dot on the geographical map. In fact, we're just one little star. On the Italian Geophysical Institute site, they mark the epicenter with a star.
Over 4,000 people were involved in the search and rescue operations, and 238 victims were pulled alive from the rubble by the timely intervention of the authorities. Earthquakes are like bullets in a game of Russian roulette. One can never be sure when and where they will unleash their destructive power.
We realized that it was a miracle. Because at Pretari, apart from the damage you can see behind us, nobody died, nobody was injured. Then we saw Pescara. We rolled up our sleeves and we said, we're still here, we can do something. But what happened in Pescara was unbelievable.
Unfortunately, the village was completely destroyed. In fact, if you go, you will find just a pile of ruins. There are about 50 deaths. These were people I knew. I had married them, baptized their children. So I'm also shocked, because when 20, 30, 40 or 50 friends die, there is a lot of internal struggle and lasting pain. We will certainly have difficulty pulling ourselves together to start again. I lived through the earthquakes in 1972, in 1997, and the one in Aquila that we felt here because we are fairly close. But for me, they weren't as strong as this one. This time, it seems the earthquake followed a line, a cursed line. Like Pescara, totally destroyed. But next to it, the village of Vezzano, which is less than half a mile away, was spared completely. Nothing collapsed. So these are phenomena that I, for one, can't understand.
Can science explain such bizarre phenomena?
The mountains are splitting apart, and you've had a succession of earthquakes running from south to north one after the other, weeks and months apart, as this set of faults, very well-known faults you can go out and see running across the mountainsides in this region, which have had big earthquakes on them in the past hundreds of years. These faults have been breaking one by one, rupturing further north along the main axis of the Apennine Mountains in Italy.
This is neither the first nor the last time that Italy will experience a big earthquake. Between October 26th and November 3rd, a series of 10 shallow earthquakes ranging from 4.5 to 6.5 magnitude hit the area of Macerata. They occurred on an active fault between the area hit by August's earthquakes and Umbria, which suffered in 1997. The process of faulting and destruction continues. 298 people lost their lives in the August earthquake. The total cost of destruction has been estimated at $2.6 billion. The Pacific Ocean, the largest and deepest ocean in the world, conceals a network of faults caused by plate tectonics. Particularly in the west, where the immense Nazca Plate moves under the South American continent at a speed of more than 2 inches a year. In Ecuador, 60% of the 16 million inhabitants live in coastal areas, including the country's largest city, Guayaquil. At 7 p.m. on April 16th, the earth rumbled and many cities lost power. It was only at daylight that the government realized the breadth of the destruction caused by this tremor. The earthquake took place in early evening, with the towns of Portoviejo, Pedernales, Manta, and Canoa among the worst affected. But the fact that the earthquake occurred at the end of the day, before people were sleeping, meant that there were fewer victims than there might have been. It was measured at 7.8 magnitude, the strongest earthquake to strike in 2016, and the largest earthquake to hit Ecuador since 1979. President Rafael Correa declared a state of emergency. 13,500 military personnel, police officers, and firemen were brought in to deal with the situation.
I am the person responsible for the zone that was the worst hit. It's a shopping area that was in full swing when the tragedy happened. The rescuers arrived at all the critical points. For the first 2 hours, the firemen spread out over the whole zone and managed to save victims. There were a lot of survivors. Then we had to look out for the dead bodies.
More than 600 people were killed in the provinces of Manabí and Esmeraldas, and over 6,000 were injured.
The earthquake happened at a time that, thank the Lord, saved lives. People were still working, they were in the streets. If it had happened an hour later or very early in the morning, it would have been much more complicated. There would have been much more loss of life.
It felt like somebody picked my house up and threw it on 40-foot seas, and it was going all over the place, you know, front and back and side to side.
The wave arrived when I was at home, and I saw how the mountain could lift itself up. I also saw some of the buildings in town move. I saw the houses opposite rise up, collapse, and rise up again.
Pedernales sits right next to the plate junction. This town of 40,000 inhabitants was particularly badly hit. Many of the town's buildings were completely destroyed.
Our house is made up of 5 floors. By the time the aftershocks had stopped, as you can see, it was a big house. 5 members of my family died in it. My sister, who is 17 years old, is still psychologically affected. She's really struggling because she saw the whole building collapse. And my mother saw the 6-story building behind me collapse. It all just fell at once. It was completely destroyed.
Some 30,000 people were made homeless. Water, gas, and electricity were cut in many parts of the region, and hundreds of miles of roads were destroyed. Many people's livelihoods have been severely affected.
The pain will always be there. Years of work, loss of hair, white hair. Everything is gone. Nothing is left. 20 years of my life. We started with a small property, a bit further away, over there. And then we moved and came here after many efforts and sacrifices. We were in debt for 18 years to pay for this construction. We just can't mess around with physics. The structure is twisted between the 3rd and 4th floor.
People were in shock. Everybody was sitting there watching. I was too. I felt shell-shocked. You know, I was just sitting there and couldn't imagine how something like this could happen. But in the weeks since, it feels like we've got help. We've starting to get some support in the community, some coordination. You know, that's the biggest thing, is trying to coordinate everybody's efforts so we can get this place back on its feet again. Businesses are starting to open, which has been great. People are starting to rebuild their houses, which is great. But we're trying to work with the local government to make sure the building standards are where they need to be so something like this doesn't happen again.
Ecuador, Bahia, and the whole region is a very active seismic zone. Throughout history, we've had seismic periods, and it's not over yet, and it's not going to change.
The depth and precise area hit by the April earthquake are typical of those in a subduction zone between 2 large-sized plates. Such mechanisms produce the most intense earthquakes known. And where the earth has shaken, it will inevitably shake again, either nearby or at exactly the same spot. The most recent buildings sustained little damage. Those that fell short of earthquake-resistant standards were destroyed, causing 673 deaths and damage worth $3.3 billion. Low construction standards of poor countries have been responsible for many casualties on the other side of the American continent. The rain brought by the arrival of the West African monsoon is vitally important for African farmers. This monsoon also heralds the arrival of what are known as tropical waves, at the origin of many Atlantic tropical storms. One such wave, which was to become Hurricane Matthew, left the west coast of Africa on September the 22nd. With environmental conditions favoring slow development and thunderstorm activity increasing, the tropical wave proceeded westward across the Atlantic Ocean. Matthew developed into a tropical storm 35 miles southeast of St. Lucia on September the 28th. The storm became a hurricane 190 miles northeast of Curacao on September the 29th, achieving Category 5 intensity the following day at the lowest latitude ever recorded for a hurricane of this intensity in the Atlantic Basin.
Hurricane Matthew started moving north and moved north quite slowly.
Where it would make landfall remained a mystery. Cuba, Haiti, and Jamaica felt the humid breath of this monster. and put coastal areas on red alert. At 7 a.m. on October 4th, Hurricane Matthew hit Haiti with winds of 145 miles per hour, becoming the country's first Category 4 storm since Hurricane Cleo in 1964. Despite preparations, the damage and loss of life on the island were catastrophic. More than 1,000 people were reported killed in the aftermath of Hurricane Matthew, as hundreds of thousands of homes were destroyed. More than 1 million people were left in need of humanitarian aid, with damage estimated at nearly $2 billion. After ransacking Haiti, the hurricane headed towards Cuba. At 8 p.m. on October the 4th, Matthew made landfall near Huauco with winds of 140 miles per hour. Land interaction with Cuba helped to weaken the storm to a Category 3, though Matthew eventually reattained Category 4 intensity as it moved away from Cuba and towards the Bahamas. On the 5th of October, Matthew made its third landfall over Grand Bahama as a Category 4 cyclone. Preparations began in earnest across southeastern United States as Matthew approached, with several regions declaring a state of emergency for coastal areas. Widespread evacuations were ordered for large parts of the coast. The storm paralleled the southeast coast of the United States over the next 36 hours, gradually weakening while remaining just offshore, before making its fourth and final landfall in South Carolina on the morning of October the 8th as a Category 1 hurricane. Damage was primarily confined to the coasts of Florida and Georgia, but 47 people died in the U.S. in Hurricane Matthew. On October the 9th, Matthew returned to the Atlantic, becoming an extratropical cyclone as it turned away from Cape Hatteras, North Carolina.
It's like a story which captures everything from the poorest to the richest, because it hit the poorest country in the region in Haiti, caused huge amounts of damage and loss of life, but then kept moving north. If the track had been 100 kilometers further to the west, there would have been a huge amount of damage in Florida from Matthew. But by the time it did make landfall in the US, it had weakened, and so it was more of a flood event than a wind event. So the US was fantastically lucky with Matthew. Haiti was fantastically unlucky.
Over 1,500 deaths have been attributed to Hurricane Matthew across the western Atlantic. And with the storm causing damage estimated in excess of $8 billion, it was also the costliest Atlantic hurricane since Hurricane Sandy in 2012. Not all countries are affected by natural disasters in the same way.
There are big differences between the first world, between the developed world, where most of insurance is written in richer countries. People tend to build stronger buildings, better buildings. They tend to follow the rules, the code in how they build those structures. If you're working in developing countries, you may tend to find a lot more risk that things are not built so strongly. There's more building in the path of floods, for example. There's less protection for people. And so there are very different challenges if you're modeling risk in the first world to if you're thinking about risk in the third world or the developing world, where the consequences of disasters can be much, much more critical to people's lives.
2016 has had its share of disasters. Fires, earthquakes, storms, Droughts. Flooding. But what percentage of these events can be attributed to global warming?
We now have techniques in order to identify what is the cause. It's called attribution studies. So it's done at a number of universities now where you run the world's climate since 1950 in one version of the Earth where you have the increase in greenhouse gases year by year, and another version of the Earth where there's been no increase in greenhouse gases year by year. And then you run these two versions of the Earth to discover how likely a particular extreme, it could be an extreme drought, it could be extreme rainfall, how likely that is in these two worlds. And that tells you how much climate change, how much global warming is influencing the occurrence of the extremes.
One thing we know for sure is that natural disasters hit the poor much harder than the rich. If it can be recognized that global warming is responsible for at least some of the disasters our living planet creates, then we can realize the urgency of approving climate policies that protect vulnerable populations.